Welcome to my next Piaggio video. I have a Piaggio engine from Vespa C, and again that's the same like the SHA uses or the Bravo or other models. And it's from my friend Kim. He bought it and it already had a tuning cylinder on from Athena. That's the old Euro Cilindro layout, just with a newer nickel seal plating. And all the parts are used. The engine is a Moped engine. That means it is not restricted. It has the large inlet. You can see back here. It has a large inlet window, and also the inlet port is pretty large. It's about 11.5 millimeters. And the cylinder kit was just mounted like it is now. There have not been any modifications to this inlet or this engine case. The inlet and the transfer ports, they're all stock. So there's some power lost in there. You can do it better by adjusting the inlet to a larger 13mm carburetor, and you can open the transfer ports a bit so that they match the cylinder ports. And then this cylinder also has some boost ports on the top, and they are mostly fed through the piston, through this window. It creates a connection between the boost port and the crankcase, where your mixture is being sucked in. And on this model the window is actually a bit too small. It only feeds about the two middle ones. So you could extend this window a bit to feed all four ports, and what we are going to do also is drag these ports all the way through the crankcase. I'll just try to show it. As you can see here, the ports are completely covered by the engine case, and you can just take a Dremel or a mill or something and then make a channel all the way past the cylinder skirt. And then it can also pull in new mixture directly from the crankcase, not only through the piston. And maybe we'll even do both. Enlarge the window and the piston a bit, and then the boost ports in the engine case. The first thing I'm going to do is enlarge the inlet to 30mm. I'm going to use a Dremel. If it's good in center, you can also take a drill, but there's always a chance that the drill will wedge and break the inlet off. It can happen. So I'm going to take the Dremel and be safe. And then I'm going to smoothen out the from the round bit to the square bit, just on the inside, to have a good flow all the way through. When I'm done with that, I'm going to mark the larger transfer ports from the tuning kit on the gasket surface and adjust it a bit with a Dremel. And on these Piaggio engines you need to be very careful all the time, because there are many parts where the casting is very thin and you can go through to the outside and create a leak, and you don't want that. So go easy on it, take only a small amount of the casting. And the same goes for the inlet port, especially on the side that's into the ignition. It's very thin in this area in here, so don't take too much, and always measure or make the control measurements to see that you're not making a hole. When I've done all the modifications to the engine case, then I'm going to take the crankshaft and the cylinder kit. Then I'm going to calculate what my inlet timing has to be, because this cutout on the crankshaft, that's what opens and closes the inlet window in the crankcase. And on this engine we have about 150 degrees of inlet timing, and for a tuned engine you can go anywhere between 180 or 195 with the typical tuning cylinders that you can get for these mopeds. And we're going to measure the transfer ports on this cylinder and use some formulas and calculations from a tuning book I have. That's the one from Graham Bell. And I'm going to show you the calculations also and how I measure the timing of the transfer ports. And then we're going to mark and measure on the crankshaft what we need to mill off or grind off. We're going to take some on both the inlet and or the opening and the closing ends. I'm ready to enlarge the intake. I'm going to use my Dremel with a cylindrical carbide burr that is rounded a bit on the end, so we don't get a sharp edge to the point where we grind. And when I've enlarged the inlet to 13 millimeters, I'm going to switch to a sandpaper tool to smoothen it out. And I'm also going to use some files to work on the inlet further in to have a good transition to make a good flow. Yeah, let's do it. And I've made a marking on my carbide burr how deep I want to go. That's what Polini recommends. It's 18 millimeters. If you go further in, you have the chance to make the hole that I talked about. I'm going to continue like that. Always take some measurements to see how far my progress is going, and that will take a while, so I'm just going to pause until now and get back to you later when I'm done with the first step. I'm done with the carbide burr. I've enlarged the intake to close to 13 millimeters. So now I'm going to switch to the sandpaper roll and smooth it a bit. I've done all the grinding with the carbide and a bit of sandpaper rolls. Now I'm going to take the file and enlarge the area from the round channel down to the square one. I'm going to use a forged file, and you can go all the way to this angle because there's a lot of material in the casting right here. So that's what it looks like from the inside. And here the inlet on the rear. I'm just going to file like that. Always be careful that you don't enlarge the inlet if you're already close to the edges inside. Always at least keep 2 millimeters of aluminium around the inlet window. And that's going to take a while. I'm just going to spend a few minutes here and then I'm going to continue the video. I'm done with the file now. The inlet is pretty large. See it from the inside here. And what I've done is I went all the way to make a funnel-like shape. You can see how large the angle is here and in that direction. There's not much you can do after that until it gets a bit risky in the sides. And now I'm going to take some finer grit sandpaper on the Dremel. And after that, for the last finish, I'm going to use a mandrel where I put a piece of sandpaper in, just to give it the last fine grinding. Yeah, let's try that. Really great tool, this mandrel. Yeah, I'd say the inlet is done now, so we can continue with our transfer ports. To get the transfers onto the engine case, you can either put some marking fluid or some dark grease on the cylinder, put it on, but it can be a bit tricky to see. In this case it didn't work really well, so I needed to make a gasket anyway, so I cut the rough shape and made the holes and the diameter for the skirts, and I'm just going to take that and press it against the dark grease, and then I'm going to have a template that I can cut out and use to draw the transfer ports onto the gasket surface of the engine case. I hope this works better than my first attempt. After I applied a little more grease, it was much clearer to see the 4 small ones here, and then this lower corner I was missing it, so now I can see where I have to cut. This one went fine. After you've cut your gasket, just double check that it fits and all the ports are free, and that the fit is as good as possible. Then you can put the gasket onto the engine case and just draw with a black marker or scrape with something sharp. Now you can see that's what I need to remove. There's a little bit on the lower part, but it matches pretty good. And there's this whole edge on the upper transfer port, and then the 4 small ones, they are of course not there at all. Now it's marked. The next thing I will do is take the engine case apart again, put the cylinder in, and then measure how deep the cylinder skirts reach, because that's how far I need to make the upper boost ports. They need to extend just below the cylinder skirt. I'm also marking where the transfer ports reach into the housing, so I can remove that edge. Don't want any sharp edges where my flow is going through. Again, I'm going to start with a rough carbide bit, remove nearly all the material I need, and I'm going to switch to the sandpaper rolls and do the rest. And you need to be very careful in this in the ignition side of the engine. You only have about 1.5 millimeters of thickness inside the transfer port. So on this Athena kit it's not a problem, you only need to remove a little bit. But with a DR or Polini layout you need to remove a lot, and you can easily go through and make a hole into the ignition. Then you need to seal it up again later, and that's a bit annoying. So less is more in this engine case. That's the rough shape of the port. Now we have a nice flow without any sharp edges or obstructions directly to the port of the Athena kit. I'm going to continue like this on all the other ports. The upper ones are very narrow, so I'm just going to dig a channel straight through to all 4 of them. You could also make 2 wide ones and then just make a small channel on the last part. Maybe I will do that, I don't know yet. I will just start to dig a groove and see how it goes from there. And then after all the rough grinding, I'm going to clean it up a bit with the sandpaper. Right now I'm grinding the small boost ports. It's a bit tricky because I don't have any tools that are small enough, so I need to use the tip of my thinnest grinding stone. That's going to take a while, but it's easier to make the larger ports for a DR or a Polini. They can just go sideways. Yeah. I will spend some time with the boost ports and get back later. I'm done with all the transfer ports. See, I made 4 small channels for the booster ports instead of large ones. And the main transfer ports are adjusted, and just give everything a sanding with a 400 grit paper, or less, I think. I can't remember, but it's not too polished and not too rough, so I think it's a good surface for the gas flow. Here's a closer view of the transfer ports. I just took the engine apart again so you can see the ports a little bit better. It really isn't much you need to take off for this Athena cylinder, especially on the main transfers. They nearly fit. The only thing I took off from this half was a bit down here in this corner, and then this straight here. Yeah. Next up is the crankshaft and the timing according to this inlet window. Now that we've done all the modifications to the inlet port, we can calculate when the crankshaft opens for the inlet and closes it again. And to do that I have this degree paper, and I've adjusted it so that 0 points directly in the middle of the cylinder bore. That's up to top that center. And I use a ruler just to set the center so that we have an even space to both sides here. Then I've put an old bearing into the bore of the housing, and then on the crankshaft itself I've made a mark that's straight across from these two holes. That's top dead center. So now I can put the bearing just loosely into the crankshaft into the bearing, and then set it, if it's like this, then you can imagine you have top dead center. That's where the piston is at the farthest point upwards. Now what you want to know is, on this side of the crankshaft you have, this is the opening, and you want to measure when this opens and closes the inlet and the rear. I'll just take the camera and go a bit closer so that you can see what I mean. Okay, now the crankshaft is at the top dead center position, and the rotation of this engine is like this. So when we are top dead center and we turn it in this direction, we can go in and look at this cutout. When it's at this mark, I've made two marks here on my Degreewheel. That's where the inlet opening, the furthest ends of on both sides. So when we're here, right in this moment, the crankshaft starts to open for the inlet. So we want to hold it here and then go over to the other side. I'll just adjust it here. And then we need to count how many degrees that is before top dead center. And this Degreewheel, it resets at 90 and goes down again. So take 90 and then plus 10 and plus 9. It can look a bit weird on camera, but it's 9 degrees here where the inlet starts to open. So we have 90 plus 19, and that's 109 degrees before top dead center. So let me just write that down. Now we want to see where it closes. So we turn the crankshaft around, and now the web comes in front of the inlet port, and it's totally closed again at this position. Now go over to the other side, again take your reading, and it's 52 degrees after top dead center, and again write that down. And you can add these two numbers. So your total duration of your inlet is 161. And we want to go up to about 185 or 190 on this engine. So that's what I'm going to show you next. I'm going to take the cylinder and measure the transfer ports, the timing of those. And based on that I can show you how to calculate your opening and closing times, so you know how much you need to grind off the crankshaft. To calculate the duration of the inlet ports, you can either have the cylinder mounted on the engine, but ours is taken apart, so that's not possible right now. If you had it on your engine, you could take a Degreewheel on the flywheel and simply measure when the duration from when the port opens until it's closed again. And if it's dismounted like this, you can take and measure the distance from the top of the port, and don't take the small chamfer width, but just a little bit inside the port and then to the gasket surface to the cylinder head. And there we have, I'd say, 35.2 millimeters. That's the distance from the top of the transfer port to the gasket surface. And to calculate this over in degrees, you can find all the formulas in Graham Bell's tuning book, but you can also use a program like Yarp's Puck calculator. I'll just take the camera again. You can just try to Google Yap's Puck calculator and see if you can find it there. What you need is this is the conrod length. It's 87 on a Piaggio engine, and the stroke is 43 millimeters. And the deck, that's the distance from the top of the piston to the gasket surface. We don't know it in this case, but we will just guess that it's half a millimeter. Then you need to put mark the timing, this button code, this field, and then put your measured distance in this field. So that's 35.2, and press calculate. And then we have 116.9, so let's just say 117. So that's the duration of our transfer ports. Next I will show you how to use that to calculate the opening and closing times. Okay, so now we know our transfer ports are open 117 degrees. And we know a full rotation is 360 degrees. So to calculate the point from top dead center to where the transfers open and when they close again, we can simply take 360 minus 117 divided, 360 minus 117 divided by 2. And that's 121.5 degrees. So that's the point where the transfers open and close in comparison to top dead center. We can overlap this point by 10 degrees on our inlet. The old inlet timing was 109 degrees, so we can go all the way up to this plus 10 degrees. So that makes 131.5 degrees. That's for our inlet timing. From that point we want to have the inlet open 190 degrees or 185 or whatever you choose. The higher the number is, the more peak power you will make, but you will lose a little bit in the lower regions. But 185 to 190 is really drivable with most kind of setups, even if you have doesn't matter if you have aromatic or fixed gearing. So let's take 180 minus 131.5, and that's to get the time after top dead center when we want to close the inlet again. And that makes 48.5. That's for 180 degree inlet timing. Let's say we have 190, then the point is at 58.5. And what you need to be careful about is not to go too high. If you get past 60 or 65, your engine starts to get really peaky, and that's a lot of inlet timing for this kind of cylinder. But this looks good. 58.5 and 131.5. Those are our new closing and opening points. So let's compare that to the old one. The new one will be 131.5, or just round it up or down, whatever you want to do. And we close again at 58.5. And that's what we want to mark on our crankshaft in the next bit. Okay, we're back with our engine and the crankshaft, still the same setup as before. Take the marking on that indicates top dead center on the crank, and then you need to rotate it to the new inlet start timing, and we wanted to go with 131. So 90, 100, 110, 20, 30 and 31. Then hold it here and then go back to your markings for the inlet timing, and the inlet opens right around here. And just to check, you can make a double check: 90, 100, 110, 20, 31. Yeah. So normally it would open here on this point, and we need to grind all the way back to this marking. And then just take the corner off here. Now onto the opposite side. That's when the inlet window is closed again. The old marking was, let's see, about 51. That's when it closes now, and we want to take that to 58. So just turn it around until the 58 mark here, there, and then make a mark on the crankshaft at that point again. So what we want to grind here, that's a bit hard to see on the camera. From that mark, there it is. And then, let me see if I can catch it. There, that's the other mark. That's what we need to modify. Now we get to the most time consuming task in this tuning, and that's to adjust the crankshaft. All the other parts are in soft aluminium, so it's nice and easy to grind, but this is pretty hard steel, and I like to use a small cutoff wheel on my Dremel. And what I'm doing is I'm cutting down to a depth that reminds of this piece, and then I go in from the other side and cut it off. And I just make the cut a little bit from my mark that I want to, where I need to be at the end, and then I can grind the rest with my carbide bits and some sandpaper rolls to make it smooth. I'll just show you how I do it for a few seconds, and then you can imagine the rest. And of course you need to be careful not to grind over in the other crankshaft web, and take some something to protect the big end bearing. I used a piece of cloth that I wrapped really tight around the bearing, so that you don't get any dust into your main bearing. I'm done with the cutting wheel. As you can see, it's pretty rough, but now we've elongated our inlet timing to about 190 degrees from 160. So now we're going to switch to another tool and continue. The crankshaft is ready. I've ground the new inlet timings and sanded it a bit to smoothen it out, and given it a really good clean. You need to wash the main bearing with petrol after you've done grinding it, because even if you take some cloth around it, you're probably going to get a bit of dust in it, and that's a killer for the bearing. So give it a really good clean and give it a bit of oil afterwards, and then the crankshaft is ready. All the other parts are ready for mounting again. The new transfers, the new inlet size, and I just need some new parts to continue, and I'm not going to show you the assembly in this video. It's the same as the other video that I did about disassembly and assembly of the Piaggio engine. Yeah, that's it. I hope it was useful, and if you have any comments, then ask me in the comment section. Ciao.